Any questions before I start on subnetting? And let's go through it today, and then we'll go back through it again Monday, and for that matter, more in depth at that time. Which pen works the best? Let's see, Mr. Lee. All right. With subnetting, what you are doing is they're issuing you a network, and then you're breaking it into smaller networks. And that's all a subnet is. It's just a network within a network. So to do that, what we're going to do is we're going to borrow bits from the host area to use with networking. Y'all follow on that? So with a Class C address, we had said the first 3 octets were the network portion, and the fourth part was the host portion. Now, if you want to subnet it, the first 3 octets will still stay exactly the same, and then the fourth one, we're going to borrow bits from it to use to do the subnet numbers. Okay? And that's what they usually do when they're giving you illustrations on these and problems on them, is in terms of a Class C address that they have you subnet. So that if we were given 192.168.4.0 as our network address, and that was the network we were given. Okay? It's got 254 hosts available in it, but they're all on the same network, which means if we send a broadcast out, they're all on the same broadcast domain, and that any broadcast goes out to everybody on it. Does that make sense? If we subnet it, we're going to break up our broadcast domains. Collision domains get broken by your switches. Okay, so that's different. So you've got collision domains and broadcast domains. In this case, what we want to do is split it up into several subnets. Okay, so your first question is going to be is, do they tell you how many subnets do they want, or do they tell you they want so many hosts per subnet? Okay, and depending on which one they give you, depends on which way you're going to look at that last byte. We're only going to be looking at just that one byte, okay, where the 0 is. The 0 address is always the network address in IP version 4, okay, and then all binary 1s for your host portion is always the broadcast address, okay, which, if it is a classful address, would actually be 255. But when we subnet it, we're going to find those broadcast addresses change, because when we draw it out here on the board, we'll see. So what we want to do is, let's first go through and do one where we want 5 subnets. And then we'll do something different beyond that with a different number. Now, when you do the subnetting, one of the things you want to also plan is that if you're doing it like here where we said we want 5 subnets now, we want to ideally allow for an extra subnet in there, extra 1 or more subnets in there for growth. Likewise, if they told you you're going to have so many hosts per subnet, when you set up your subnets, when you do the subnetting and you create the subnets, you want to make sure not only that you have the minimum of subnets that they tell you about, that the minimum number of hosts that they tell you they want, you want to allow for some additional hosts per subnet. Does that make sense to everybody? Because ideally, things are going to grow for you, right? that your organization is going to grow in some way, you're going to get more devices, and that you're going to need to put some more devices on a subnet. Or that your organization is going to grow and you're going to need another subnet because you've got some more area, or you opened up another division or something or another. And if you don't include for an extra subnet in there or extra devices, host on it, then when growth does occur, you're going to have to go back and redo the whole process again. And that means go out and number everything all over again. Okay? So you do want to normally plan growth on it. Now, when we look at that field, we've got 8 bits. 2, 3, 4, 5, 6, 7, 8. When we're looking to see, based on the number of subnets we want, we're going to look from the left. If we want to know in terms of how many hosts we need per subnet, we're going to work from the right. Okay? But what we're going to end up doing is we're borrowing bits for the subnets. And that way so many bits for the host. So if we need 5 subnets, and remember what I just made the comment also about the broadcast and the network address. So there's some addresses you can't use. But as far as the subnets, you can actually get away with them on it. Actually, you don't normally use the 0 one on the subnet. No, you can use that. It's just in the host numbers that you're real worried about it all. So that we're going to look and see how many bits do we need to borrow to do that. If you remember when I taught you the binary, we normally numbered 1, 2, 4, 8 from the right, correct? For determining number of subnets, and this is only for determining number of subnets, we're going to number from the left. The same numbers, but backwards. Y'all follow on that? That's only for determining number of subnets. It's not for determining what that value of that number is. Okay? It's just for figuring out how many bits do we need to borrow. It's going to be this number plus 1. That doesn't sound right. That should be plus 1, but it still doesn't come out quite right. If we borrow 1 bit here, that's going to give us 2 subnets we can have, because we can have a 0 and a 1 there. Y'all follow on that? If we borrow 2, we actually can have 4 subnets, because there's 4 binary numbers we can get in those 2 positions. We borrow 3, we can get 6 of them. Okay? Somehow that's not working right. Yeah. That still doesn't work right. So in this case, we need 5. So we're going to have to borrow 2 positions to get 5 of them. No, we're going to have to borrow 3. Correction. We're to get 5 subnets in there. Okay? Because we can have a 0, 0, 0. 0, 0, 1, a 0, 1, 0, a 0, 1, 1, a 1, 0, 0, and then we have a 1, 0, 1, a 1, 1, 0, and a 1, 1, 1. However, yeah, as far as the host does, as far as the networks, that will work. So that would give us 8 here. So we're shifting off a column on it. Okay, on how many subnets are available. So we've definitely got 5. If we'd only borrowed 2, we would only hit 4, which won't meet our requirement. Now, we're going to look at what the network addresses are, the host addresses, and the broadcast address for each network. Okay? In all cases, everything I'm going to write down in here are all preceded by this number, but I'm not going to write that number into the chart here, really completing it out. But remember, all of the numbers I'm writing in here are going to actually be this number in front of it. Does everybody follow on that? So the network address for this first one would be the 192.168.4.0, because we've got 0 here followed by 5 zeros, because our host number would be all 5 zeros for the network portion of it. Does that make sense to y'all? So we've got 0. Now, on some equipment, that network 0 won't work there. So that one, sometimes, usually in your questions, I'll tell you that it includes that network 0 is usable. Okay? This one has a 1 in this third position. Remember back to our original correct numbering system, a binary. That 1 is actually in which position? It's in this position, which really comes back to our 6th position, which is the 32's column. Does everybody follow on that? So on the second line, we've got a 32 for our network number. Okay? The third line has got a 1 in the second position, but 0's in the other 2. Which means the 1 is in which column?
10th. 64.
What's the second position of your whole byte? If the third position was the 32's, what's the second one?
It'll be 64.
64. The next one's got a 1 in the second and the third, which puts a 1 in which columns?
32 and 64.
The 32 and what?
64.
64, and those added together are what?
96.
96. All right, I'm going to pause right there on doing this one, because what I'm going to do is I'm going to show you there's a pattern to this whole thing. Okay? But you really don't have to fill out the whole chart. You don't have to sit there and calculate the whole chart to fill out the whole chart when you start doing it. And when you hit test questions, you don't have to do the whole chart anyway. They're going to ask you what's the network address for the 5th subnet or the 3rd subnet. And you only have to do your calculation down to whichever point it is. Does everybody follow on that? You don't have to do the whole thing to do it. All right. Host numbers. Or let's go over to the broadcast number. The broadcast in binary here for this first one would be 00 in binary, and then all ones for the remaining 5 positions. Does everybody see on that? Because broadcast numbers are always all binary 1. And the only host area we got left is those 5 positions. So we put all binary 1s in the host position, because we borrowed the first 3 for the subnets. So now the first 3 positions of what was the host area belong to the network. So everybody follow what we're doing. So in binary, it would be this number. So what would be that broadcast address for that first network? We've got a 1 in which columns? The 1s, and then what? 2, 4, 8, and 16, right? All right, so what number does that come up with? 31. So our broadcast address for that first network is, subnet, is 31. Really it is 192.168.4.31. Now follow on that? Because I'm leaving off the first 3 octets in the chart. And y'all look at the charts in the book and stuff, they're going to give you the full address. But we're just going to save work on it, on my hand, of having to write out all the same numbers again and again and again. And likewise, when you all go to do it on test, you don't have to worry about the first 3 numbers or whatever on it either, because you know they're repetitive, so you know that part's there. Now, for the host numbers, they're going to range from 000 and then a 1 for the first position through the last host position, which is going to be 000, and then it's going to be all 1s except for the last position, because if it was all 1s, what kind of address is it? It's a broadcast, right? So it would be 11110. Y'all follow on that? And that's the binary form. However, let me show you something else on here. This address here is 1 bigger than the network address. Now follow that? Well, it's going to be 1, the first one. It's going to go through this one, which we can sit here and calculate it. If y'all calculate it, what number do you come up with? Hmm? 30. Which is what? 1 less than that number, right? Y'all see that?
Where is this coming from?
Hmm?
Where is this coming from? The zeros and ones?
The first 3 positions is the subnet number. The last 5 positions, because we didn't borrow out of them, is still our host number.
And this works on everything?
Hmm?
And that works on everyone or just that one in general?
Does this works exactly the same on any subnetting you do?
So you're always going to have that 3 that you leave there?
No, it's not always 3 here. It depends on how many we need to borrow for the number of subnets we need.
Alright.
Because back here, remember, we said we're going to have to borrow 3 of them to be able to get 5 subnets, because that was our rule. And to be able to have 5 subnets, it takes 3 bits to do that. If we only needed 4 subnets, we could have done it in 2 bits. Okay?
Okay.
And I'll do another one with a different number in just a minute, after we get this one done. So on the second row, the network address is 32. The host number, and these all got little periods in front. The hosts are going to range from 33. Because again, if we draw it out right here, we're now changed down here to where that's a 1. And that's a 1. So the first one would be 33 then, because it's a 1 in the 32s and a 1 in the 1s. Y'all see that? Because everything across this second line should all have a 001 as the first part of the byte. Does everybody see that part? It's the last part that's changing across here. The numbers range to 001 and then 4 ones and a 0. Which if we add that all up together, happens to come to 62. Broadcast, changing just that 1 0 here to a 1. So now we've got 6 ones on it. So what number does that add up to? 63. Okay? Now, I want y'all to notice, and we can keep on doing calculating them out just like we did all the way down the chart. Okay? Now, I want y'all to pay attention to something else here. Notice as we built row 2, and actually started row 3 and row 4, how do the numbers all change?
By 32.
By 32. Our difference right here in the very beginning. Okay? And we can fill out that entire rest of this chart just off of that. Because that third row then is going to be 32 bigger. That's going to be 65, 95, 94. Helps if you add correctly also. And 95. Notice also, remember this number here, 1 added to it gives you the first number on the next row. Y'all see that? So you don't have to sit there and go back to the binary continuously all through the whole chart. Once you get your pattern built there, on those first 2 rows, you can calculate the rest of the whole thing out. Now the book's going to show you in terms of calculating everything out. Okay? But if you watch your patterns on it, y'all see what's happening right there. Everybody follow on that? Y'all see how the numbers are? So then each of these is whichever subnet. Now your question will be whether or not subnet 0 is usable. And your questions on your test will tell you, is subnet 0 usable? Okay? So this could be first, second, third, fourth, fifth one, or it could be certain with this one's the first, second, third, fourth, fifth, depending on whether they tell you that or not. Cisco equipment now is going to normally always use the subnet 0. So go ahead and normally just count that as one of your subnets. Okay, so if they asked you a question about the third subnet, that's the subnet they're asking you on. Because they're going to ask you what's the network address, or is a certain address a usable address on that subnet. Does that make sense? And you got to see, does it fall in this range? Okay? But you got to be able to calculate it out to get to there. All right, questions on what I just did up here with this one? Now, so let's do a second one. Let me take my N off there. Let's go through with another one. Now let's this time use 3 subnets. Okay, we need 3 subnets on this one. Everybody follow on that? How many bits are we going to need to borrow for 3 subnets?
2.
How many?
2.
2. Because when we borrow 2 bits, we can get 3 subnets. We can get actually 4 subnets, right? You got to borrow 2 because we only borrow 1, you only get 2 subnets. Y'all follow on that? So, all of our subnets are going to be 0, 0, 0, 1. Just drop down a little bit more. 1, 0, and 1, 1. That's in the, this is in the binary column, okay? So our first subnet is going to have 0 for the network number, right? Our second subnet is going to have what for its whole network address? So 1 in the second column, but then because it's a network address, it's all zeros the rest of it. So it's 6 zeros follows it. So what's that number? It's on the board. Because I gave you the column numbers there. Second column is which column? 64s, isn't it? So we got a 1 in the second column. So that's the 64s, and we got zeros in every other column. The first one plus the last 6. So that one's got an address of 64. The third one has got a 1 in the first column, and then 7 zeros, right? So that's what? 128. And the fourth one has 1 in both of them. So that's the 64 and the 128s, and that was what number? 192. So the third one's actual network address is 192.168.4.128. Y'all follow that? First line, first host, 0, 0 in the network portion, plus it's a 1 in the very last column. So that's 5 ones, 5 zeros followed by a 1. So 0, 0, 5 zeros, and a 1, which gives us what? 1. The high end of it's going to be 0, 0 in the network portion. All 1s except for the last position's a 0. So it's a 0, 0, 4 additional, 5 additional zeros, sorry, and then a 1. So effectively, 5 ones, I mean, not 5 zeros. So we got 0, 0, 5 ones, and a 0. What number does that add up to?
62. 62. 62.
62. And the broadcast is 0, 0, and then 6 zeros. 6 ones, I mean. I'm getting my 1s and 0s mixed up. Sorry about that. So 6 ones. So that gives us what?
63.
63. Now, based on what I already told you when we did the other chart, What are we gonna get in row 2 for the first host?
65.
65, very good. Where did he get 65 from?
It's one higher than
1 plus 64 is 65. Or 64 plus 1 is 65. Y'all follow on that? Broadcast. What will be our broadcast for the second row?
127.
127.
127.
Apparently there's a wall between us that makes y'all's voices all disappear when it gets up close to me. There's some kind of sound barrier across there that we can't see. So this number is going to be what?
126.
126, which we got either one of two ways, either adding 64 to this number or coming one off this number. Y'all follow on that? That one we know is correct because the next number is one higher than it. So then you fill in this row the same way. So this one is 129. This one is 190. And this is 191. This one's 193. And then 254. Put my period in the wrong place. And we got 255 over here. I'll follow on that. Now, notice something here. Before, we had 254 usable addresses before we subnetted it, right? Now we don't. We've actually lost 7 of the 8 addresses. Okay? We've lost 7 of those addresses in this case. And the other one before that we did, you actually lost more. Okay? So you're going to lose some usable addresses when you subnet it. Does it make sense to everybody? But this one and this one's still the same. I really wrong lost 6 out of that chart. So now there's only 248 usable addresses. And here's 254. So we don't have as many host addresses we had, but we've got them organized better. So one balances the other. Does everybody follow on that? And how that's done? So that's going through with 3 subnets. We roll through on this quickly. So there's where all of your numbers are. There's your ranges. Okay? But if you follow the patterns, you can calculate them faster than people that have to sit there and calculate each one all the way out. Now, some people actually can get, I guess they're doing the first 2 and then they're calculating everything from that. People can steal it off right off the top of their head, a few people. I can do it pretty quickly, doing some calculations, but not that fast. I still got to get them to teach me that part. So you're going through 1. We're going and looking to see where our split our line are. Does everybody see that? How many bits are we going to borrow? And then we set it up from that. One that you will use pretty often it actually comes from the other direction. 'Cause actually, you're not going to, a lot of times, subnet Class C networks anymore. You used to, because remember that was where 2 million network addresses they issued out to you were a Class C address. But now you're going to do a private address in your network normally. And you may well do, like the school did, with a Class A using 10. And then they've got 3 octets to play with. Okay? And what you will often find, and we may well have here at school, but I don't know, they haven't ever told me how they did their subnetting. If I had have set it up, it would be this way, but I'm sure they're doing something similar, but not necessarily exactly what I'm going to picture for you. Is that you could do that, since you've got 3 octets to work with, you could assign different octets to different locations and just use this last one as your host. And for instance, with the college, that I might well use this number to be the campus plus building. Okay? So that I might say that, since I don't think on any of our campuses we've got more than 9 buildings, I might say that campus Floyd is 10, Walker is 11, Catoosa is 12, for instance. And then, for instance, at Walker, that I could say that the last number would tell me which building it was, so that if it was building 600 on Walker, I might use 16 in here. Y'all follow on that? And if it was building 500, it'd be 15. The 15 would tell me, the 1 would tell me that it was Walker, and the 5 would tell me it was 500. Y'all follow on that? So you don't necessarily always do what we just did in that chart, but you need to know how to do that chart, because that's the stuff they're going to ask you on tests. But in real world, to give you an example, and then this one I may well use as the room. Okay? And put the room numbers right there. Or figure out, if we've got room numbers that get bigger than that, have a system of those room numbers on it. That most of our room numbers that I know of fall under 255. Okay? So that y'all are in a 211, I think. Is that correct? Does that sound right for the room? What's it say up there? It says 211. Okay, so we're in 211. So we could have 211 right here and then the host number. Now something pops up in the system about there's a problem on a computer that has an IP address of 10.13, assuming we said 13 was Catoosa, 10.13.211.5. We could walk in the room and go, all right, that's machine 1, 2, 3, 4. Something's wrong with his machine. Or that somebody just did something on it they shouldn't have done. Because he hadn't been paying attention to me in class, so I didn't know what he was looking at on the computer. Right? You may be checking the obituaries to see, is Dr. Watt dead, or is he really alive up there teaching us today, or did they send in some double for him? So you can do that approach on this also. Y'all follow on that? And that's why you will see a lot of organizations for what they use for their network number and their private network numbers that they use inside their organization is using 10. Is that you can just sit there and not have to sit there. Just think about what we just did. You'd have to remember, all right, the first one you assigned to something. The number didn't have any relationship to whatever it was of how your stuff actually is split up within your organization. Okay? This way, you can just go into the number. You don't have to look back at your master chart to see, wait a minute, now where is that machine at? Just the number looking at it straight itself would tell us right off where is that machine. without doing any looking up, as long as we know what the code system is. So everybody follow on that? Which makes it real simple to do it then. Okay? Likewise, you can do something similar in IP version 6, but remember on IP version 6, they've given you the third hextet to work with. But think about that. You've got 65,000 subnets available to you in that hextet. And that you can play off numbers and columns and say certain things. That if it starts, that in the first, you've got 4 numbers, remember, in there. And you can play with those 4 numbers to have meanings to you. So that if we were doing it here for the school, I might say that the first position in the hextet is the campus. And know what 1, 2, 3, 4, 5, 6, 7 on a F, we could have 15 campuses. And then the second number be the building. And obviously that would work right there. So if we saw in the address, we could just look at what the actual number showed us, that it was a 1, 1, and then something about how the third number works to get us, the third and fourth number to get us in terms of the room. Might not, it would do it quite as cleanly as this, but you could come up with an easy system on it. Does everybody follow on that, on how functionally you can do it? But in reality, of what you got to do for the test is this approach. Now, here's where I was going to next. And this is one where you'll see used quite often. Because you'll connect routers to routers. Now, if you connect a router to a router, that is actually uses a subnet for that connection from the router to the router, and the only devices on it is the 2 routers. Does everybody follow on that? So we got a router, and we got a router. And we got a switch off here, and we got some PCs. And we got a switch off here, and some PCs, another switch off here, with a variety of PCs. And we may well set up our network where each of these is separate subnet. Y'all follow on that? However, when we set it up, and what we're going to look at on Monday, I'm going to show you in terms of variable length subnet masking, VLSM, allow us to get more efficient on this. But with the way it is right now, you got to use a full subnet here too. But how many addresses do you need on the subnet? 2. 1 for here and 1 for here. That's all that subnet will ever have is 2 addresses. But you got to use a full subnet under the way we're doing right now. Okay? If you just had a bunch of routers hooked together, so you had a number of subnets for that, but then did something different when you came to the actual PCs sitting out here and everything, you could actually divide it to do on those. And you have seen that. You will see that sometimes in some large organizations that have a bunch of routers. And they may well put the routers onto their own network. Okay? But if you do that, all you got to do, how many devices did we say we need for that subnet? 2. If we know how many devices we want, that's where I told you wrong on this one. It's going to work like I told you right here. From this end, it's going to work the other direction. That'll work the same way from this end. From this end, that we're going to, if we know the number of hosts we want, and in this case we want 2 hosts, we would come from this end to figure out how many, where we're going to split it at, and then how many networks we can actually get. And actually you will normally do for this one that get a subnet that only has 2 positions. When we do the VLSM, you'll see where you can actually do each of your subnets, this one, this one, this one, and this one, all having variable lengths off here to make an increased efficiency. So in that case, we would borrow 2 bits. No. Correction. We'll keep 1 bit. Okay? Right. No. We should borrow, but we've got to do 2. Because we can't just keep 1 because the network address uses 1 of those. So we're going to have to go with 2, and that's going to give us 2 hosts right here. If this one count correctly. Because we're going to have the broadcast and the network, 2 of them are gone. So we would have to keep 2, so we could borrow up to 6. Now, think about how many networks that can get us. And we can have 64 of those networks on there. Okay? So we can have 64 subnets with 2 hosts per network. Obviously, that chart would go on downstairs somewhere. Okay? Of how big it's going to be. So we had 64 lines on. But in that case, we know how many hosts we want for it and the ups. Questions on that? Is that making some sense to y'all? So let's go backwards. Take that illustration off the board. And let's go with 14 subnets. Okay? If we go with 14 subnets, how many positions are we going to have to borrow? Four. Because we need more than 8, and it's less than 16. Okay? How many hosts are we going to have per subnet? $14. Look at the 8, the 4, and the 2 are usable. So that's 12 plus 14. If you're not sure, we'll see in just a second. So in binary, there's 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, etc. First network address is going to be 0.0, right? First host is going to be 0.1 through what number? 0, 0, 4 zeros followed by 1, 1, 1, 3 ones, and a 0. I'll see why I told you you need to use hex a lot of times from this stuff. We're crazy on zeros and ones. So in that case, we've got 0, 0, 0, 0, 1, 1, 1, 0. So that gives us what number? 14. If our host numbers range from 1 to 14, how many hosts do we have per subnet? 14, which is the number I told you just a minute ago, right? So notice we've got now that we're going to have 14 subnets and 14 hosts per subnet, so you can multiply that out and that tells you how many hosts you got to play with. Okay? And our broadcast address would be 0.15. Second line. So one in the fourth position, which is which column? The 16s, right? So that means that's going to be 16. That's going to be 17. That's going to be 30. And that's going to be 31. And you'll see the same thing developing again like I told you before. We had 32s and we had 64s in there. Now we've got 16s in this case per one. Okay? And so we can create the third line because we know then it's 32, 33, 64. Where did I just come up with that from? I don't know. 16 and 30 is 46. And that's 47. And the next one here would be 48. And continue on down for our full 14 lines we wanted, but actually there's 16 lines because there's 2 more subnets there. Y'all follow on that? And notice we really wouldn't have to, if we wanted to know about the 7th line, you really don't have to fill in all of this over here on each line. You could just calculate on down to the 7th line. So then there's the 64, and there's the 80, and then there's the 96. Okay? And then we could calculate out that line from there because we know it's the 97. We know these are ranging about 13 actually on them, okay, from what we've already established up there. So that means that one's going to be 13 is 110, and that one's going to be 0.111, which says this should be 0.112, but 16 and 96 is 0.112, right? So we've verified our calculation there. And so now we know that 99 does fall in the 7th subnet. Okay? Because they asked you on the test about which subnet does 99 fall in. Questions on that? Have y'all got that all straight? Y'all need me to go through any more examples on it today? Now, you do have that workbook there in Blackboard, okay? The only problem is you don't have the answers. I'm trying to think what's the easiest way, because I've got to put them in, I've got to put them in where it's ADA compliant to give them to you. Mark them. So long as I don't use illustrations on it, and I think it is in text format now for me, I can go through and probably bold the answers for you so the answers show in bold. Okay? So, let me try to go back and do that this afternoon. And I've got one student coming in to do cabling for the online students. I've got some more of them they haven't answered back to me of when they're going to come. And then I may have some registrations, but I don't have any on the schedule right now. Because if y'all don't need me to go through another one, I'd rather not jump into the next piece here today. I'd rather y'all get this down through the weekend before we go to the VLSM. Does that make sense? Because VLSM it's working off of this, but changes the illustration. Actually, I tossed you a little bit of that information already. Okay, but then I'll go through and show you exactly how to do that. But it complicates it a whole lot more, which is the last part of chapter 8, if I remember right. So that's next week's chapter, really. Okay? So, and then we can come back through and do this again if we need on Monday morning also. Is that make sense to all of y'all, what we've done right here? I've got some handouts out there. I don't think there's a video lecture on subnetting. There is on the VLSM, but I don't think there is on just regular subnetting for some reason. Although it's rather odd that I don't have one on subnetting. Okay? Is that, so all of y'all are following on the idea of this? Well, a lot of times the subnetting gets more complicated on some, but if you can see the patterns, it makes it easy. And when I learned the subnetting, when I first learned it, Microsoft didn't really teach about the subnetting, they just taught you about what they had you just see in the 255s and zeros. They just saw you on class things, but subnetting itself, Cisco goes a whole lot more into and expects you to know. And then when I took the class from them, they were sitting there building this whole table, and I sat there and started throwing out answers for on down the table real fast on them. They're going, how'd you get those? And I went, once we got the first 2 rows done, I could do the whole rest of the table real quickly because I knew exactly what numbers to add all the way down it. And it really doesn't even take the first 2 rows. It only takes the first row plus the first entry on the second row. Y'all see that? Now, VLSM, we're going to be doing parts of it in one way, part of it in another way. So you're mixing things together. So you've got to understand this to do the VLSM. Okay? Is everybody following that? So if there's not questions, I'm going to let y'all go early today. Unless y'all got complaints on that. And then we can figure out, I can find something else to talk to you on. But I have a feeling y'all just soon exit out at this point. But we can talk later if we can, longer if we need to. Okay. And what I'm going to do, Mr. Spurlock said you came by for me to sign this stuff last week.
Yeah, but I had to have the office sign it.
Okay. You were here both days, right?
Yes,
Who came in late this morning?
I did.
I
I
need to
got
mark
hung
you.
up in this traffic. They shut the road down.
Oh, yeah.
Okay, so let me mark you here first before you walk off. Okay? So that my attendance matches yours.
Yeah, the traffic was going good for a little bit, then they just shut the whole road down.
Wow.
What road?
Up here at the bridge.
Oh, okay.
I was sitting there at that red light for like 20, 30 minutes.
As they're doing the bridge work there.
This side, going that into Ringo, was all the way down here to the college road right here a while ago.
I'm taking the back roads home.
Yeah.
Okay. Jesse. All right, got you one.
Thank you.
Because that needs to match that. If they
Yes.
ever question, I've never had them question on it, but if,
Yeah, it's not, if they ever want to look at it, it needs to match.
Mhm.
Saves us from auditing.
all right, I will see y'all Monday morning then.